Thanks for joining us, everyone. Good afternoon. Today we're going to be talking about the Illinois Commercial Stretch Energy Code. So to get started here, today your presenters are myself, Robert Schlorf, and my colleague Ryan Siegel. Who we are CDEC, the Smart Energy Design Assistance Center. Simply stated, our mission is to reduce the energy footprint of Illinois and beyond. So what do? We're an applied research program at the University of Illinois. We assist buildings and communities in achieving energy efficiency, saving money, and becoming more sustainable. We help facilities become more energy efficient. We educate, we research, and we advocate for a greener future for us all. Today's presentation is brought to you by the IEPA. CDEC works in conjunction with the IEPA to deliver energy code training and energy code technical assistance throughout the state. CDEC is a preferred education provider with the ICC. This presentation upon completion of this presentation, attendees will receive a certification of completion. This presentation is also, we will also receive AIA credit for this participation. The AIA is the AIA credits may be slightly delayed for this current presentation, but just slightly. So keep that in mind when keeping an eye out for your credits in the future. If you provided ICC or AIA information to us, we will submit credits on your behalf. Energy code assistance. If you have an energy code question, you can reach out to us at energycode@illinois.edu, or you can call our 800 number there, 214-7954. We do ask that you send an email. Email is often the best way for us to pass the question around the office, make sure that we have a cohesive and agreed upon response, and we get that response back to you in writing. That might be a little bit more helpful for you. So we do generally encourage people to reach out by email, but of course you are welcome to call as well. Also on our website, smartenergy.illinois.edu/energy code, you will find schedules for our workshops and webinars, as well as all of our past webinars. This webinar and all of our past webinars is being recorded and will be uploaded to our website. So you can access those old webinar recordings there. Also on our website is on-demand training modules. These training modules are self-paced self-paced modules on the energy code, different topics related to the energy code. Upon completion of those courses, you take a quiz and then you receive a certificate of completion for that course. Additionally, on our website, we have some blog posts and smart tips talking about energy code and energy efficiency subjects. So CDEC Energy Code training series for this year. So we are today, the Commercial Stretch Energy Code, February 20th. We have two upcoming presentations next month that talk about the 2021 IECC updates, and then we'll be talking about simplified code compliance and existing commercial buildings later on this year. Registration link there is at the bottom there. And as I said earlier, the archive presentations listed above today's presentation, you can find recordings of those presentations on our website. For anyone who missed it or needs to go back, and if you didn't hear something quite right, we do have those recordings available. So as I said, based on popular demand, essentially we've been getting quite a few questions on the update to the 2021 code. So we do have two presentations that we've added to our schedule this year to cover the 2021 IECC updates. We've split these presentations into residential and commercial. So the residential component will be on March 19th, and then the commercial component will be on March 20th. Registration link there is again at the bottom. The Illinois Energy Conservation Code, the state of Illinois has moved on to the next energy code. So the 2021 Illinois Energy Conservation Code is now in effect. This code became effective as of January 1st of 2024. So any projects applying for a permit within the state of Illinois after January 1st of 2024 will need to comply with the new 2021 code. Access to this code, we often point people to the codes.iccsafe.org site. This is how many of us in the office access the code. We find it to be a really nice, really simple way to access the code that's easily searchable, well organized. You can use a Control F function within there to search for certain terms. That site also allows access to other model building codes as well. To access the Illinois amendments, you can go to our website, go to the energy codes page. There's a link there that'll take you to the CDB website, or you can go directly to the CDB website where they have links posted with the Illinois specific amendments as well as Illinois amendments with the modifications shown. At some point in the future, we do expect there to be a Illinois amendment document available, a cleaned up document. And when that is available, we'll link it to our website for access there. This presentation does not really get into the Chicago Energy Transformation Code, but if you are needing to access that code can also be accessed on the code's ICCSafe.org site. So if you're dealing with any projects that are under the jurisdiction of the 2022 Chicago Energy Transformation Code, you can go to that site to access that full code. The learning objectives for today's presentation. By the end of this presentation, we expect you all to be able to summarize the stretch code development cycle and progressive improvement within the stretch code, compare the 2032 stretch code to the base code, identify how the stretch code improves resiliency and reduces pollution, and identify how the stretch code makes future building improvements safer and more cost-effective. And I believe we have a first poll question here that we'll launch. And those questions are, the first question there is, have you heard of the Stretch Energy Code before today? The Illinois Commercial Stretch Energy Code. Have you heard of that code before today? Yes or no? And then the second question, are you involved in projects that plan to comply with the Illinois Commercial Stretch Energy Code? Yes or no? Trying to get an idea of who has heard of this code before. What are the plans for it? Is it already in some people's plans or not? Seeing quite a few people have already heard of it. That's good. All right. Like we'll go ahead and end the poll there. So it looks like a good chunk of people have heard of it, but we also have quite a few people who haven't. And then looks like most people are not involved with projects that are looking at the Stretch Energy Code, but we'll forge ahead and give you the information anyway. Pass it over to Ryan here.
Well, thank you, Robert. I do see a question that did come in the chat. If you do have questions, do post them in the question and answer function so we don't make sure we don't miss those. But the question that did come in the chat that I did see was that typically building codes are to be followed at the time the design process is started. Can you clarify if the IECC has the same stipulation as opposed to projects that are moving into permitting having to be redesigned to meet the current IECC? In the state of Illinois, the codes that you are required to meet are based on when you apply for your permit. So as Robert noted earlier, Illinois moved to the 2021 IECC as the basis of the state Energy Conservation Code for permit applications beginning January 1st of 2024. So it's not based on just when the design process started, it's based on when you apply for your building permit. So hopefully that'll will clarify. They're also noting, making sure that understanding the version numbers can be a little wonky here because we are talking about the stretch code. I believe the stretch code has been redated back to 2023 to help alleviate some of the confusion between 2023 stretch code, 2024 base code, 2024 IECC. So just something to be aware of that I believe they've redated that back to 2023 to try to help reduce some of the confusion for that. So touching on the commercial stretch code and what it is and where did it come from. The Illinois stretch code has come out of CEJA for that. So signed into law back in 2021. Part of that legislation was that the state of Illinois, and particularly the Capital Development Board, will develop and stretch code for jurisdictions that may wish to go above and beyond the base code for that. So this also allows for jurisdictions that may not have had a energy code at the time the state adopted theirs back in 2009. Previously, residential construction, if you didn't have a adopted energy code before the state did, then your option for energy code for residential buildings was limited just to the base code for the state of Illinois. With the stretch code, that is now enabling those jurisdictions to have some flexibility and some options for adoption of better codes. So what a stretch code is, so this is making a pre-established text. So rather than jurisdictions having to write an entire code themselves, this gives a simple framework for jurisdictions to use. And this also can enable much more consistency across jurisdictions. So you don't end up where, one jurisdiction has one stretch code and another one has a different one, and they're all different. That is something that we definitely saw over these last several years, where even the city of Chicago, recognizing the difficulty and time and effort involved in maintaining developing and maintaining an entire set of building codes was a fairly arduous task. And so they have since transitioned to using the standard code text that is published by the International Code Council, along with some local amendments to that. This makes codes a little bit easier to enforce, as well as for design professionals to be able to port that from area to area. So as far as what this is, so we now have a stretch code, and additionally, it's a little bit unique in that it allows 4 steps over time. Noted earlier, here it's indicated as the 2024 stretch code that was relabeled 2023. And so we have these steps that progressively increase the performance of this code over time. So normally building codes develop over time in a less predictable manner than people might like. And so with this, the stretch code is providing a predictable path going forward. So if you do have a client out there that wishes to say, hey, I want to build an even better building than I'm required to, you as a design professional can assist with that and say, to what future performance level would you like to design to? So given that these metrics are known as of today, this is using the 2006 International Energy Conservation Code as the basis of the reference. You can predict and say, okay, I can design you a building that would comply with the goals set forth for the 2031 Energy Code. That is quite a dramatic difference, but this allows for designers and design professionals to improve their designs over time in such a way that you're able to have some better performance with that. So with that, the code added a few definitions for the stretch code. So for cooking, we do have a definition now of commercial cooking appliance and commercial food service establishment, understanding that these are dramatically different from your home cooking appliances. And this we'll get into as we touch on some of the electrification ready or electric readiness provisions in the stretch code. The code is at this point recognizing that commercial cooking appliances, the options available are rather limited at this point. And so some of the provisions may not be applicable to commercial food service establishments and for commercial cooking appliances for that. Also added definitions for an EV capable space. I won't read this definition to you, but making sure that there are provisions in place for a future installation of electric EV supply equipment. Now that's something else that I believe we'll also touch on at a couple of different points. There was a new state law that came into effect January 1st that also requires this for new single-family homes as well, regardless of if you're in a stretch code jurisdiction or not. One other thing I should mention about the stretch code before I get too far is this stretch code is not something that is required across the entire state of Illinois, and it is up to the local jurisdictions if they wish to go above the minimum code for the state of Illinois, then they will need to pass a resolution or other applicable legislation that would adopt the stretch code. And we'll also touch on, there's a few different parts and pieces that they can adopt with the stretch code, or they can just adopt the stretch code. Also added a definition for replacement cost. This varies a little bit from the 2024 IECC public draft with committee action report, which is the basis of the commercial provisions of the code. So for those of you who may have attended the session on the residential stretch code, that is based on the 2021 IECC, but the commercial provisions are mostly based around the 2024 IECC public draft for that. So the replacement cost here in the stretch code is defined as the cost to construct or replace the entire building with equal quality, construction type, and square footage at the current market rates. So that is something that's will be talked about when we look at substantial improvement for that. So substantial improvement, this is where the stretch code really bumps up a little bit from when you have just an existing building that we'll touch on. Once you get to a substantial improvement, then the requirements elevate a little bit. So substantial improvement, noting the repair, construction, or rehabilitation or other improvement, the cost of which is 50% or greater of the replacement cost of the structure. So if you look in the 2024 IECC, they focus on market value. The stretch code focuses on replacement cost of the structure. So also noting that if it has if the structure has sustained substantial damage, as defined in the IBC, then repairs are considered substantial improvement. And what substantial damage for the IBC is would repairing the building cost 50% or more to return it back to the condition it needs to be. So kind of trying to get away from avoid people saying, okay, well, I'm going to do this improvement here that's only 10%, and then I'll do another 10%, and then I'll do another 10%, and continue on like that, just to avoid this substantial improvement provision for that. So generally speaking, when we see 50% or more of replacement cost in a project, oftentimes these are very invasive, almost gut rehab type of projects for this. So that's probably where we're going to see substantial improvement for that. As far as some of the updates, so applicability still remains the same. So you might have a residential building If you have mixed residential and commercial, the residential provisions apply to the residential portion, commercial to commercial portion, and so forth. And then if you have taller buildings, those are commercial buildings subject to the commercial stretch code first, where there are provisions that may reference back to the residential, that would apply similarly as it does in the base code. So there is some additional requirements for construction documents. Some of this including electrical infrastructure, where we talk about electric readiness provisions. So that's, or spaces in the electrical panel capacity, making sure that those are in those construction documents as well. Beyond code compliance pathways. So as part of the stretch code and part of CEJA, there is alternative compliance paths that are performance driven that may be used to show compliance with the stretch code. They also would qualify as demonstrating compliance with the base code as well, since the stretch code is above and beyond the base code. So what is called out in the legislation is FEIS and analogous, the Passive House Institute International with that, and the Appendix CC or Zero Energy Appendix that's found in the IECC. So those are deemed to be compliance pathways. So if you are doing a passive house project, all you need to do is submit your passive house paperwork, and that completes your compliance your compliance demonstration for the purposes of both the stretch code or the base code. Recognizing that ASHRAE 90.1 is an alternative compliance path for the IECC, there is language in the stretch code that requires a few provisions from the stretch code, even if you use the ASHRAE 90.1 2022 version. There are a few additional provisions such as electric ready and EV ready that need to be complied with for the project as well. Also for ASHRAE and some of the additions, do have, again, some additions that need to be added onto your 90.1 compliance in order to make sure that it does align with the Illinois stretch code. So if you do have, as noted earlier, some of the electric ready provisions, some duct testing and controls, along with making sure that you're doing your system sizing and system acceptance testing for that. So horticultural lighting is referencing back to the cannabis facilities, subject back to the legislation for cannabis here in the state of Illinois. Electric storage ready. The code also updated this to call out the new International Fire Code, recognizing that several jurisdictions may be on an older International Fire Code version, and as energy storage systems and the provisions that those are built to improve over time, and the code catches up in their provisions, wanting to make sure that we are adopting the latest versions of those codes for that. So Electric Ready did update the fire code reference to the 2024 International Fire Code for that. Similarly, for EVSE, updating that to make sure that even if a jurisdiction is under an older IBC, that the stretch code will reference the latest 2024 edition for those requirements. And with that, go ahead and pull up our next poll here. First question, what is the planned basis for most of the language in the commercial stretch energy code? Is it ASHRAE 90.1 2022, IECC 2021, IECC 2024, or Passive House? Second question, which of the following paths is sufficient for the commercial stretch code compliance? IECC 2021 prescriptive, passive house, LEED 4.0 new construction, or ASHRAE 90.1 2022 energy cost. I had a question come in regarding municipalities adopting the stretch code. At this time, given the earliness in the process, municipalities have not begun to adopt the stretch code as far as we are aware. There have been several communities that have expressed interest in adopting this, but as the text is still being finalized, most municipalities that we are aware have not begun to adopt the code yet. So this adoption would take place beginning July 1st, would be the earliest enforcement of the stretch code for that. As far as the did have a question come in regarding the full text of the code publicly available. The Capital Development Board does have text on their website for that. I will caution you, the document does appear rather daunting, as it's roughly 600 pages. Part of that reason is because the 2024 IECC public draft with committee action report has not been is not in an easily accessible place. The Capital Development Board has, in essence, published the entirety of the 2024 public draft with committee action report as part of the stretch code. So it does include a lot that's beyond just the stretch code. All right. Looks like most everyone has had a chance to answer. All right. The plan basis for most of the language in the commercial stretch code comes from IECC 2024. So the 2024 is where the most of the commercial comes from. 2021 is where the base code or the residential is coming from. And which of the following paths is sufficient for the commercial stretch code compliance? Correct answer is passive house. So passive house, if you show compliance using that, you are compliant with the stretch code. ASHRAE 90.1 2022 energy cost does not work. You can use the ASHRAE 90.1, but it has to be on energy basis, not energy cost. LEED does not qualify at this time, and the 2021 prescriptive does not comply with that. So, and with that, I'm going to turn it over to Robert to talk about electric readiness.
All right, thank you, Ryan. So as Ryan just said, we're going to talk about the electric ready provisions contained within the commercial stretch code. Just to start out, the commercial stretch code does not ban the use or installation of any gas appliances. These electric ready provisions are within the code to encourage preparedness for electrification within our buildings, decarbonization of our buildings, eliminating on-site fossil fuel use, as well as providing options for future building owners. So these electric ready provisions are essentially saying, you know, if you're going to install a gas appliance, okay, but we also want to make sure that you have electrical infrastructure in place so that the future owner of the building could fairly easily swap out that gas appliance or fossil fuel appliance for an electric appliance. So that's kind of the overall goal of these provisions within the stretch code. But again, they do not ban the use of natural gas at all. We are only encouraging electrification and providing options for the future. So the electric ready provisions within the commercial stretch code requires new R2 occupancy commercial buildings to include electrical infrastructure that would be required at the installation of a new electrical appliance. And these provisions cover space heating, water heating, cooking, clothes drying, and transformers within the building. So again, this applies to R2 occupancy commercial buildings. And a quick reminder there, R2 occupancy is usually multi-unit housing. So we're talking about apartment housing, condos, co-ops, congregate living facilities of 16 or more occupants, or townhouses. So these are the building types, or the commercial building types that these electric ready provisions will apply for. So first, electric ready space heating. So space heating is split up into two provisions here based on capacity of the units. But the essential idea, as I kind of just said, is that if we have an existing natural gas furnace, or the project is built with a natural gas furnace, we want to make sure that there is electric infrastructure near that location, near that fossil fuel furnace, gas furnace, so that it could be swapped out for an electrical space conditioning equipment at a future date, most likely a heat pump, as we see here on the right side. There is an exception to these requirements that if there is already a branch circuit existing near that gas or fossil fuel appliance that has the capacity needed to serve a heat pump sized per C40311, then these provisions do not apply. So it's either the branch circuit already exists, or we're going to ensure that it exists by following these provisions. So low capacity space heating. So we're talking about fossil fuel warm air furnaces that are less than 225,000 BTU per hour, or fossil fuel boilers that are less than 300,000 BTU per hour. These appliances shall be provided with a dedicated circuit complying with the following here. So we want that circuit to be within ready access. We want it to be nearby, so it needs to be within 6 feet of the installed equipment. We want to make sure that that circuit is sized properly. So we want that circuit to be sized for a future heat pump space heating equipment that is sized per C40311. We want to make sure that if we're putting a circuit in there, that it has enough capacity to serve a new heat pump unit. And then lastly, we want to make sure that this additional circuit is labeled for future heat pump space heating equipment. Labeling is incredibly important, especially when we're talking about the longevity of buildings and buildings serving a long life and continuing on after one owner to another. So we want to make sure that we're preparing for this electrification. We're including this additional circuit as an option for the future. We want to make sure that that's labeled appropriately. Moving on, so other space heating equipment, basically any space heating equipment that is above the capacities listed in the previous provision will need to follow this provision. It's very similar. It's going to sound very similar, just with some slight differences. The code is calling for a continuous raceway from the branch circuit panel of the junction box within the same space as the interior equipment, or within 3 feet of the exterior equipment. Again, we're just trying to make sure that we're close enough to where connection is simple and we don't need to necessarily call in additional workers or extend the project lifespan to install a new appliance. Again, we want to make sure that the junction box, raceway, bus bar, electrical panel conductors, and conductors are all sized to house the additional load of whatever the new equipment might be, but we want to make sure that that's sized to match the same load as the fossil fuel equipment. So we're keeping an eye on the size there, making sure that the preparation, the electrical infrastructure that we have for the future is sized properly. And we also want to make sure that we're providing enough space within the electrical panel for overproduction devices, again, sized to serve the same load as the fossil fuel appliance. Okay, moving on to water heating. So water heating is similar. They've broken it up again by capacity basis. So the first capacity tier is any fossil fuel water heaters that have an input rating of less than 300,000 BTUs per hour. Again, this is going to sound similar. We want a 30 amp, 240 volt branch circuit to be within 6 feet of that fossil fuel water heater. We want to make sure that that branch circuit is labeled for future electric water heater. And then since we're talking about heat pump water heaters here, heat pump water heaters do require a certain amount of air circulation to operate properly. So we want to make sure that those have enough sufficient clearance around them. That clearance is 3 feet by 3 feet by 7 feet tall, or 700 cubic feet in volume. You need to ensure that that space is left clear and available for the future unit. If you can prove that there's sufficient air circulation, then those dimensional requirements do not apply. So moving beyond the units, so these are units that are above 300,000 BTU per hour for water heating. Again, this is similar to the larger space heating requirements, where we want to make sure that we're continuous raceway is within 3 feet of the exterior equipment or within the same interior space. Again, making sure that this equipment is sized to serve the same loads as the fossil fuel equipment. Providing sufficient space for the overprotection devices that are again sized to the same, and then again labeling, making sure that we're labeling this electrical panel. I think we probably all understand the frustrations of an electrical panel that isn't properly labeled. I think that's pretty frustrating to come across, even if you're just trying to find which circuit got tripped. Okay, moving on, electric ready cooking. So as Ryan mentioned earlier, the stretch code now contains a definition for commercial cooking, and that is to set up this provision. So any non-commercial fossil fuel ranges, cooktops, and ovens shall be provided with a dedicated circuit. This circuit's calling for a 50 amp circuit, again, within 3 feet of the appliance, and again, labeled for future electric cooking appliance. Residential drying. So this is aimed at fossil fuel clothes drying serving individual dwelling units. These units will need to have a branch circuit nearby that is 30 amp 240 volt circuit, again within 3 feet of the appliance, and again labeled for the future use. But again, this specifically is for fossil fuel clothes dryers that are serving individual dwelling units. For non-residential drying, we have somewhat similar to our larger space heating and larger water heating requirements here. Again, with the continuous raceway located in the same space as the appliance, properly sized electrical infrastructure that meets the same capacity as the fossil fuel appliance. We want to make sure that there's space in there for the overprotection devices, and again, proper labeling of this equipment. And then lastly, on-site transformers. So enclosed spaces and underground vaults containing on-site electrical transformers on the building side of the electrical utility meter shall have sufficient space to accommodate transformers to serve the loads that we just talked about. So essentially, we don't want to build this building such that there is not enough space to put in the correct size transformer. That would not be the best way to set up the building for an electrified future. So we want to make sure that there's enough space there for the required transformers if those future loads are in place. All right, and here I believe we have another poll question before we move on. And these questions are, does the commercial stretch energy code require building electrification? Yes or no? And then which appliance is not included under the electric ready requirements of the commercial stretch energy code? Kitchen stove, water heater, space heater, clothes dryer, or none of the above?
So we had a question come in regarding fossil fuel backup generators, if they are covered under the stretch code or not. There are not provisions that we have seen that cover backup electrical generators, particularly for things such as the electric ready provisions, because that would seem a little redundant to have a backup for the backup generator. But yeah, so those are not in the stretch code as far as required or not.
I'm going to go ahead and end the poll here. It looks like the first question, the correct answer there is no. The stretch energy code does not require building electrification. Full building electrification would mean that fossil fuel appliances are not allowed. So the stretch code does not ban fossil fuel appliances. It only contains provisions for electric readiness. And then the second question here, which appliance is not included under the electric ready requirements of the stretch code? All of those appliances are included. So the correct answer is none of the above. And I will pass it back to Ryan to talk about some other key provisions.
All right. One other question that did come in regarding the electric ready. Question is, for the electric ready, does the wire need to be pulled in, or is it just have to be piped? That depends on which provision it is and where you are. Commonly, what we see, and it will vary by the provision. Generally speaking, the smaller ones require the wiring to be installed. If you are in the higher tier for things such as your domestic water heating or space heating, then that's just has to be piped, and the raceway has to be run for that. So, as far as other key provisions, we've got EV capable, making sure that we've got EV capable spaces, using raceway or cable assembly where allowed by jurisdiction. Needs to be installed within 3 foot of the outlet within 3 foot of the capable space. That does not require that to be a receptacle. The junction box is allowed to be the outlet for that. So they want to make it size to meet the provisions for that. Again, this goes back to that 30 amp, 208 or 240 volt. I believe it's 30 amp. It might be 50 amp for this. But again, 405, 14.5 for that, for EV capable. As far as heat pumps for new construction, if you don't use heat pumps for building conditioning, so either an electric furnace or fossil fueled appliance for building heating, then you need some additional efficiency credits for that. So it's a little bit, can be a little bit tricky how it's worded, but that's kind of the basis of this. Is if you're not using heat pumps, then you need an extra 25% of the credits that we'll talk about here in a couple of slides for that. Something we also should touch on as far as heat pumps for building conditioning. We see this electrification or electric readiness can be very problematic if people install this under the legacy method of thinking, where I need 100% resistance backup heating for the heat pumps, recognizing that there is much better technology that is now available on the market that can maintain capacity and continue operation even at much colder temperatures, down well below 0 degrees Fahrenheit. And, you know, analogous to this, we don't see too many fossil fuel appliances with the 100% electric resistance backup provided there either. You know, if it breaks, I'll call someone to have it fixed. As far as heat pumps for additions, so similarly in additions, if you don't have heat pumps for the addition, then you need to get some additional credits for that. So this is similar to the new construction. Also calling out here that we'll talk again later in the presentation, additions have a lower threshold of as far as how many additional efficiency credits they need for that. So speaking of additional efficiency measures, alterations that are substantial improvements need to comply and get at least 50% of these credits for the substantial improvement. Again, we're talking over 50% replacement value in this. And you may notice, if you are familiar with the new tables from 2021 IECC, these numbers are substantially higher than the values in the 2021. Part of that reason is the increment or the value of the various measures has changed substantially. And so whereas in the past, you know, a lighting upgrade might have gotten you 10 points or maybe 7 or 8 points, now it might get you 60 or 70 points. So this provides a little bit better granularity as far as how much impact a measure has. So rather than, whereas previously moving up by 1 point would represent perhaps a 0.5% change in building energy, now it might be as little as 0.1% change. So making that a little bit easier for people. Substantial improvements. So if you trigger the substantial improvements, now you need to have the electric readiness provisions and some more of our energy efficiency requirements for that. EUI, that is another change, is for the performance pathways. It is now using site energy use intensity rather than utility cost as the metric. This was set forth in CEJA, and part of this is understanding that different energy sources may have different, substantially different unit costs to them, but we want to measure what is the actual energy efficiency of the building, not just what is the cost efficiency, negating all other features of that. So that's something to be aware of in the performance, is it's going to need to use energy use intensity, not energy cost. So something else that has been removed from the IECC text is energy efficiency trade-offs. So with the 2024 IECC, there is renewable energy credits or renewable energy points and additional energy efficiency points. The 2024 allows you to trade between those two categories. The commercial stretch code allows that trade to be done only in one direction. So you can trade renewable energy and load management and do more energy efficiency in lieu of those, but you cannot install more renewables or more load management in lieu of energy efficiency. Fenestration orientation, this is coming up from the base energy code. We're bringing it up into the stretch energy code as well, since it's not in the 2024 IECC. This was incorporated in. So again, trying to avoid providing a lot of glass area or a large proportion of glass east and west facing, because east and west facing are very hard on the HVAC system and comfort and glare issues. Appendix CI for total building performance. With that, substantial improvements, again, need to be energy ready. Again, since this is looking at ASHRAE 90.1, making sure that we are aligning those with the CEJA requirements. So using site energy rather than cost for that as well. All electric. This is not part of the base code. However, this is something that jurisdictions may adopt with adoption of the stretch code. So a jurisdiction may decide we are going to be just a stretch code community, and that's good. Other communities may say, well, we're going to do stretch code and we are going to adopt the all electric appendix as part of this. So Appendix CG has provisions for all electric appendices for that. And so with that, new commercial buildings would apply with their provisions, and the stretch, again, stretch code, making sure that we're addressing purchased energy versus on-site energy, and being aware of preheating and trying to avoid electric resistance where possible and where feasible, but there may be some need for it to temper some outdoor air for that. And with that, let's go into one more poll here. This is asking question 1, to meet the definition of substantial improvement, a project would need what percent of the replacement cost of the structure before the improvement or repair is started? 30%, 45%, 60%, or 50%? Second question, new commercial buildings that do not include heat pumps for space conditioning are required to achieve additional efficiency credits under Section C406. True or false? I do see a question that we have coming in regarding comfort conditioning, recognizing that terms have been updated over the years. Illinois still uses the term comfort conditioning. This is comfort conditioning is recognized to be not for such as freeze protection. Freeze protection would be providing some conditioning, not for comfort. So that might be one example of that. And part of this is, what are you going to use to demonstrate that this is not for comfort? So freeze protection might be thermostat settings. It may be something where, typically temperature based, where I'm going to only activate it when it's below 40 degrees or what have you. Excellent question regarding incentives. Yes, because the base code, anything you do above the base energy code, even if you're in a jurisdiction that has adopted the stretch code, the base code is still the minimum standard for calculating utility incentives. So anything you do above the minimum base code may be eligible for incentivized by the utilities. Excellent question. With that, let me go ahead and wrap up this poll here. To meet the definition of substantial improvement, the project needs to cost at least 50% of the replacement cost of the structure before improvement or repair is started. And the second question, new commercial buildings that do not include heat pumps for space conditioning are required to achieve additional efficiency credits. That is a true statement. So excellent. Most everyone picked up on that. So with that, I'm going to turn it over to Robert to touch on existing buildings.
All right. Thank you, Ryan. Take a few more slides here to talk about existing buildings, and we'll get back to a few more of these questions. So, as Ryan was just talking about, this is connected a little bit to what he was discussing with this table C40611. If a commercial building is undergoing an addition, that addition needs to achieve at least 50% of the number of required efficiency credits from that table. There are some listed exceptions here for certain occupancy groups, additions under 1,000 square feet, or additions without replacement or new equipment, covered by table C40332 or section 4042. So again, additions to commercial buildings need to achieve at least 50% of the number of the required efficiency credits in the table. Again, somewhat similar to what Ryan was discussing, additions that do not employ heat pumps within their design need to achieve at least 125% of the number of the required efficiency credits. So in this case, since the addition is not choosing to use heat pumps, we actually are requiring higher efficiency, more points from the efficiency credits table to compensate for the lack of heat pumps and the high efficiency of heat pumps. So this applies if the additions are using purchased energy, not electricity, for space heating or surface water heating. So if you're purchasing natural gas or another fossil fuel, additions using electric storage water heaters that are not heat pump based, or additions that are served by total heat pump space heating capacity that is less than the peak space heating load at the design condition. So this is essentially saying that if your building isn't entirely conditioned by heat pumps, that this provision will be enforced. So replacement or added roof equipment, roofs with insulation entirely above the roof deck. If you are looking at replacing equipment, the roof curbs need to be raised or replaced to enable future installation to be added to meet the C402 levels, or 17 inches from roof deck to the top of the curb. This does not require the insulation to be added as part of the equipment replacement. So the photo on the screen there is an existing commercial roof with rooftop solar. The unit that we're looking at is an aging unit. It's probably 20 years old or so. So if there was a project project to replace this current unit and the project fell under the jurisdiction of the stretch code, that unit would need to be picked up, the curb would need to be raised at least to 17 inches, and then the new unit could be placed down on the new curb. This would not require removing the solar to add more insulation. All of this is requiring is that we prepare for additional insulation in the future. We have the opportunity to increase the curb height when we're lifting the unit off, so we're going to go ahead and take that opportunity, increase the curb height at that point, and then later on when the roof needs replaced, we can deal with additional insulation at that point. Some exterior lighting alterations. So lighting power, if you're increasing lighting power by more than 400 watts, if you're increasing exterior lighting power by more than 400 watts, all of the exterior lighting, including beyond the planned alterations, so what was there originally, all of it needs to comply with section C 405.5, which is the lighting power section. So if you are adding more than 400 watts to exterior lighting systems, all of the exterior lighting needs to comply with 405.5. A related but slightly different provision here is that if the lighting scope, both new and replacement fixtures, is more than 400 watts, then this provision applies. So the previous provision was if you're adding 400 watts, and this provision, it's if you're touching 400 watts or more than 400 watts. In this case, if you're touching more, if the lighting scope touches more than 400 watts of exterior lighting, all of the exterior lighting needs to comply with section C405.2 lighting controls and C408.3 commissioning. There is an exception here for luminaries that are under 50 watts and that have operating daylight shutoff. Under 50 watts is not a high bar to hit with today's LED lighting fixtures, so that could be a fairly easy exception to aim for. And daylighting sensors are continuing to increase, and a lot of fixtures even have them built in nowadays, so it's possible that exception's a fairly easy target to aim for. And I don't believe we have another poll to wrap things up. No, so we are at the end of our presentation here, and let's take a look at some of these questions.
To answer one, the slide deck and today's recording will be posted to CDAC's website. Our webinar website does have not only the upcoming webinars, but also the archive copies of our past webinars. So both the video recordings and the slide decks are posted there for viewing. So in case, recognizing that there are probably many people that might have wished to participate or attend today, but you can go ahead and send them over to our website and they can pick up the recording of this. I do see there's a couple of questions regarding the all-electric appendix in association with what's commonly known as the Berkeley decision out in California. That is an unknown at this time. That decision only applies to that region of the legal system. That is a quite surprising argument out there. We will see what might transpire elsewhere.
I see a question about costs for electric-ready buildings. I don't have any of that information offhand, but I know that there are some studies about electrification in buildings and electric-ready buildings, so there should be some cost information out there. I'm thinking maybe RMI, the Rocky Mountain Institute, may potentially have some of that information, but there is some analysis of what electric-ready, the consequences of electric-ready on the cost side out there. If you search in the right places, it is there.
Yeah. And as I had alluded to earlier, electric readiness can be very costly if done poorly, or it can have fairly minimal additional costs if done well.
I see a question at the very bottom that's easy. If you have additional questions related to this code, can you reach out to us? Absolutely. You can always reach out to us with questions code related. It doesn't have to be the base code. It can also be stretch code related. So absolutely.
Let's see here. Oh, question on Okay, porches, additions. There is some provisions in the code for small additions. If I recall, under 1,000 square feet, there are some provisions for that to minimize any impact for very small additions. Again, our website, smartenergy.illinois.edu/energy-code. And if you have problems finding it, again, reach out to us, energycode@illinois.edu, and we can send you the link that way as well. With that, I want to thank everyone for participating today, and thank you for your questions. Again, if you do have any more, reach out to us, energycode@illinois.edu. On behalf of Robert and myself, thank you and have a great day.